Hello everyone, we're going to do a quick tutorial on coroutines. So we're going to first of all have a look at a simple coroutine, and we're going to move on to look at building a cut sequence using them. So let's get going. We'll create ourselves a cube. This cube is going to be the focus of our little demo. We're going to use it to spawn a lot of physics-based bouncing balls, and then we're going to write a little cut sequence to yank them back into the cube and make the cube grow. Very straightforward, very simple little example. So we'll just remove the box collider from our cube so it doesn't get in the way of anything. Just turn that off for a moment. And then this cube is going to bounce some balls, so we're going to need to create those balls. So let's create a sphere, and let's give it a rigid body. Let's give it some mass, and give it some collision detection. Just make a prefab for that ball. So we'll call that ball, and we'll drop our sphere into it. Okay, so we've now got a basic prefab. Now, what we're going to do next then, delete the sphere out of the scene and go and write some spawning script for our cube. This is what I call it, cube script. Okay, so we're going to create our start function as a coroutine for this. And we're going to spawn some balls every few seconds. So we're going to make a while loop that's just going to keep running, and then inside that loop we're going to create a new ball by doing an instantiate on our ball prefab at the cube's position with no rotation. I'm going to cast that to be a transform. So then we'll add some force to it. And let's create a new vector 3 with let's go with Unity engine random value times, let's say 2000 minus 1000. Give it some X force in either direction to make it go upwards, and let's make it go across the screen a bit as well. So multiply that by 2000. Take away 1000. Just a couple of closed brackets there. Right, so we created a ball, instantiated it, and added some force to it, and then we want to wait a while. So let's wait for a minimum of 1 second plus maximum of 2 more seconds. And then we'll create another one. So let's attach that cube script to our cube, and let's specify the prefab. Okay, so very straightforward coroutine. We run that, it starts creating balls and bouncing them around the place. In fact, I'd quite like them to have a bit more vertical velocity than that. So let's actually make the vertical velocity a bit random too, 2000 plus up to another 1000, let's say. See what that looks like. Yeah, that's looking kind of okay. Maybe we'll have them happen a little faster. We'll just take down that value to be a maximum of another 1 second. So there we go, a very straightforward coroutine to spawn things and get going. Okay, so what we're going to do next is we're going to use coroutines to create a cut sequence that goes and looks at the balls which are still in play, and then zooms them all back into the starting cube, and then grows the cube to make it look like it's got fatter for some reason. So very straightforward kind of thing to do, but it'll involve us writing a few little helper functions, so it'll be quite interesting, I hope. First of all then, we need to actually add a script to that prefab, those balls, and we need that because we want to be able to find them, and the nicest way of doing that is probably to have them use a static list. So let's create ball script. Okay, so we're going to create ourselves a generic static list of ball script. Let's call it all balls, and then we'll just do an awake function, and in that we'll do all balls to add this, and we'll do an on destroy function, and we'll do all balls dot remove this. Now we've got a simple way of finding all the balls if we need to, and it's just if they roll off the edge of that platform, let's destroy them. So if transform.position.y is less than -5, let's say, destroy the game object. There we go. So let's make sure that hasn't messed anything up. We'll apply ball script to the ball prefab. There it is. So let's see what happens now. Seems to be working fine. Great. Okay. Perfect. So we've now got a list of all the balls. So we're going to need a little bit of GUI in our cube script to say when we're going to actually run our cut sequence. So let's write an onGUI method. We'll retrieve the balls, and what we're going to do with that is we're going to run our cut sequence. So we're going to do that by doing start coroutine, and let's call it cut sequence. And now we just need to go and write that function. So enumerator cut sequence. Okay, leave it like that for a moment. Now we probably want to be sure that we don't do this whilst we're already doing it. So what we'll actually do is we'll stick a bool in here called running sequence. And if we are running the sequence, we're not going to display that GUI button. So the first thing to do in here then is run sequence. And the last thing we're going to want to do is stop running the sequence. Okay, we've bracketed our cut sequence pretty well. So now what we want to do is we want to go and look at each of the balls. We want to go and move the camera to go and look at each one of the balls before we pull them back in. That sounds like a fun thing to do. What we're really going to need to do to that then is actually have some kind of function that can move an object around. So let's write one. So first of all, we'll write it as a coroutine because we're going to call it from within that other coroutine to make it wait. So we'll just call it move object. We'll pass in the transform of the object to move. We'll pass in the position we want it to move to, and for the hell of it, let's pass in the time we want it to take to get there. Okay, so we're going to initialize a time variable to 0, make it sure it's a float, and then while that variable is less than 1, we're going to do a loop. So basically this is going to be for a lerp, it's going to go from between 0 and 1. So we also need to know where that object is at the moment, so let's call that original position, and we'll take that as being the object to move's position. So we've now got a starting point for a lerp, and we've got over here an ending point for a lerp. So all we really need to do in this routine is say that the object to move's position is equal to vector3 lerp, the original position to the ending position at point t. Then we need to increment t by time.delta time divided by the amount of time we wanted it to take, and then we need to yield return null, so something else gets to have a go. Right, so that there is a very straightforward coroutine that will move an object to a position that we pass in. So first of all, let's go and look at all the cubes, all the balls first. So what we're going to do is we're going to find out the current position of the main camera. Oops. Transform.position, and that's so we can set it back later on. So then let's do a for next loop on all of those balls. So that's ball script, sorry, for each ball in ball script dot all balls. So we now need to work out where we want the camera to go near that ball. So I'll tell you what we'll do. We'll go and look the position of the ball at the present time, and we're going to want to move one world unit towards where the camera is from that ball position. So our target position then is equal to the ball's current position minus vector 3 dot forward. Okay, so that's where we want the camera to go. So now let's move the camera there. So we're going to yield return start coroutine, move object, camera.main.transform, and we want it to move to the target position, and let's take 2 seconds to do that. Oops, the close brackets there. Then let's wait for half a second. And then let's go and move on to the next one. When we finish doing all of that, we need to move the camera back to where it started from. So let's move camera.main.transform to the original position in 2 seconds. Okay, so that'll do for the first part of our cut sequence. We'll go and look at each one of those balls in turn using this coroutine. So let's go and have a look at that. So what have we got an error in? I can't spell properly. There we go. Gone. Yeah. Okay, so some balls start bouncing out. Click on retrieve the balls. We go and look at this one. A bug, and that's because all balls can get destroyed when they're going through this loop. So what we actually need to do here is actually turn that into a copy of the list by doing .toList on it. Do toArray, it seems to be faster. And then we just want to make sure ball is not equal to null, which it will be if we've destroyed the next ball. So if the ball is equal to null, we'll just go around and do the next one. Right, let's run that again. So now if we run it and have a look at it and click on retrieve the balls, we're going to zoom over, can't look around the place. It's sort of not working, and the reason it's not working is the balls are still moving while we're trying to go and look at them. So that's kind of, we've chosen a position which is where it was when we entered that coroutine. So we chose the position here, and then we moved to it. But by the time we get there, the ball's gone 2 seconds later. So what we really want to do is actually, when we start this cut sequence, is we actually want to set the time scale equal to 0, so nothing is moving, and we probably want to reset it. Let me get back here. Now we've got a couple of problems with that. One is we're using time.delta time in here, and the second is we're using a yield wait for seconds here, which is based on game time. So what we really need to do is not use game time. So there's a way we can do that. We could, for instance, create a variable called last time, which is equal to the real time since startup. And then rather than using time.delta time here, we could do time.real time since startup minus last time, which is effectively the same as delta time, and then set up last time to be equal to the real time since startup. So that will fix our movement. So the game's frozen, but we'll still move in real time. This wait for seconds is going to be a bit more difficult. So actually what we should do there is probably write our own wait for seconds. So let's write a function called wait for real seconds 0.5. So there's another technique we can use. We're going to return a coroutine, which is a function of wait for real seconds, and that is going to have a float time parameter, and then this is going to return start coroutine wait, and then we'll pass in the time. So we'll now write that wait function as a coroutine. So you can see the technique we're using here is to stop needing to write start coroutine each time we're building it into the function. That's all we're doing. So what this is going to do is it's going to take the current time since startup, and then while time.real time since startup minus current is less than the amount of time we want it to pass, we're just going to yield return null. Okay, so we've now got wait for real seconds, starts this coroutine, and then that lets us wait for a real amount of time. So let's see how that works out. So we'll start it up again, let it bounce out a few balls. Click on the retrieve balls, perfectly lined up that time, and again, and again. Maybe that's exactly what we wanted. And off they go, moving again once we've finished. Clicking it again, we'll obviously start the whole sequence once more. Great. Okay, so let's now call all of the balls back into that central cube. So you can imagine that's not going to be particularly hard to do. So once we've gone and looked at them all, I'm going to move the camera back to where it started, and then we're going to go for all of the balls in ball script.allballs.toArray. Make sure it's not equal to null, and then we're going to now start the coroutine to move that ball back to the central position of the cube. So we're going to move ball.transform to our current transform.position in 2 seconds. Well, we're not going to yield it because we're going to move them all back in one go. We know how long it's going to take, so all we need to do here is yield return new wait for seconds. Oh, no, our new wait function. Return wait for real seconds 2. Oh, actually, we want to go and destroy all those balls actually for each var ball in ball script. All balls to array. Destroy ball.gameObject. There we go. So look at them all, go back to the original camera position, call them all back to the center, waiting for that to complete, then destroying all of the balls, and then expanding the size of the cube. Okay, so let's write another coroutine that will scale our object. Yield return start coroutine size object. Scale would be a better word, wouldn't it? Scale object. We want to pass ourselves and let's say we want it to be 2 times the size. So we're going to use a little coroutine for that. So it's going to write one of those. Right, enumerator scale object. The object we want to scale, and the size. So new scale is going to be equal to object to scales local scale times size, and then unsurprisingly we're going to have something that looks very like this loop here, so let's just copy that a second. So we don't care about the original position, we want instead the original scale is object to scale dot local scale, and then object to scales dot, it's written here, object to scales local scale is equal to the lerp of original scale to new scale given the value of t. And that should just about do it. That should be something that scales an object over a period of time. In fact, we could now actually make that even when the time isn't running. So let's do that. Okay. An error. What have we got? Oh, forgot to pass it a time parameter. Okay. Make it double the size in 1 second. We'll pass a time parameter to our function. Cool. Okay, let's go. So bounce out a few balls. Then look at them all. Up to the center. In they all go, bang, and the cube gets bigger, and then it starts bouncing them out again. Hurrah! So let's do it again. Look at all the balls. Back to the center, bring them all in, grow the size of the cube again. Hurrah! Okay, that's a quick look at how we can do some simple stuff with coroutines. One thing I would point out is lerp is very useful inside coroutines, but it's a bit annoying that every time you do it, you get this very abrupt movement. It just goes from point A to point B. What you really want to do is ease that movement in some way. So let's have a quick look at how we can do that. In this project is also an easing library, and I'll show you how we can use that right now. So what we can do is we can go back to our script, and we'll have a look at this move to object. So let's also pass in a couple of optional parameters to our moving function, and the first one is going to be a delegate. So it's going to be a function that takes a double and an easing type and returns a double, and we'll call that easing function, and then we need an easing type which we'll call ease. Now we're going to make these default parameters, so we're going to make them equal to null here. Okay, now here's a little trick. We're really going to need some easing functions, so we're going to set easing function equal to easing function question mark question mark. And what that does, it says return this if it isn't null, and if it is null, return the thing that follows it. So what we're going to do is we're going to by default use easing dot ease in out, and then that easing function needs to be linear. It's not null, sorry. It's easing type dot linear. So that would make it work exactly the same way as we'd normally allow it. In fact, I'd really like those parameters the other way around, because you're much more likely to want to do an in-out first. So let's actually just take this second parameter, last parameter rather, cut that out of there, and let's just put it here. So we'll put them in the other order. Okay, so we pass the type of easing we want, and then we pass null for an easing function, and by default we ease in and out. So you could ease in, ease out, ease in and out. Right, so having done that, the great thing about easing functions is all we have to do is pass in the value of t, and it will return us a value of t that has been shaped to a curve. So we can just call easing function, pass in the value of t, and then we need to pass in the easing type we want. So it was ease, and there you go. Okay, sorry I hacked that around a bit, but basically two new parameters. So if we just run it the way it is, it won't work at all. Returns a float. Sorry about that. Returns a float, takes a double. That's very annoying. Okay, so we just need to change our function here to say it returns a float. Hooray. Right. Okay, so running it normally, we've got a bit of moving the object, so we're moving the camera. Everything's the same. We're using linear, so it's exactly the same as if we were doing a lerp. Okay, so let's now pass a value instead of linear here when we move the camera and when we move the balls. So when we move the camera, is our cut sequence down here. We're moving the camera in each of these. So we're going to pass in now the easing type, and we'll use sine. And when we move the balls, we'll pass in the easing type quartic. So they're different curves. Basically, sine's a very smooth curve. Quartic is very much faster in the middle and slow at the start. So let's now call retrieve the ball. So you can see camera now neatly goes faster and slower as it gets to it. Pull it out again, and then the balls are going to come in using that. Whoa, very fast in the middle, slow at the ends. And then we'll do one more for that scale of object. We'll just do the same thing for scale as we did for move, so I can do it again and not be quite so bad at doing it. So we'll pass in an easing type ease, and we'll make it equal to easing type dot linear by default, and then we'll pass in a func double easing type float easing function, and we'll make that equal to null. And again, we'll just do exactly the same as we did there. Copy that easing function, stick it in here, and then we'll call it easing function on the value of t. So now when we do our scale, let's have a look at where that scale was happening. So we can simply pass the easing function, and let's try quadratic, but this time we're only going to ease it in rather than in and out. So that's going to be easing dot ease in, and you'll see what the effect of that is. Oops. Sassing function, obviously. There we go, and then we've got helps if you call it with both parameters, doesn't it? Okay, there we go. Right, now bounce a few out. Dum dum. And look at them. as you see, the cube started to grow slowly and then it's whacked up to full power, and that's what happens if you do an ease in. If you did an ease out, it would be the opposite effect. It would just slow down at the end of the operation. So there you go. We've covered a lot there. We've covered using easing functions at the end there. You've seen how to build a variety of different coroutines that can be used as tools to create something like our cut sequence here. And you've also seen a very easy way of making a start function be a coroutine in order to instantiate our balls at the right moment in time. Hopefully that's been kind of interesting. Thanks for watching.